Okay. Okay. Nitya Ranjan?
Yes, yes.
Yes, yes. Yeah. Please
Okay.
proceed. Proceed with your
Okay.
presentation. Hmm.
Yes, thank you. So, I'm Nitya Rajan, and this is my co-author Shalini. We are presenting the paper Unveiling the Multidimensional Risk Landscape of Human Trafficking in India, a K-means approach. So, this is our content. So, we'll start with an introduction, go to the literature survey, speak of our objective, methodology, results, conclusion, and finally our references. So, I'll get started. Uh, Actually, according to National Crime Records Bureau, there were 636 reported cases of human trafficking in just 2022. So this is an alarming, sorry?
Yes, yes. Continue. Continue.
Okay, this is an alarming statistic, and it underscores the need for urgent research and to create proactive measures to combat this huge issue. There are also many forms of human trafficking that the government also tracks specifically, such as forced labor, child labor, sex trafficking, prostitution, forced begging, organ removal, debt bondage, domestic servitude, and forced marriage. So these are all various subtypes of human trafficking that the government monitors separately. Moving to our literature survey, the first paper we presented, we would like to speak about is by TWIS. In 2020, it was published, basically a multinomial logistic regression analysis, but on databases detailing cases of human sex trafficking. So to identify the risk patterns, it's on a very different kind of database, but it's also using machine learning for human trafficking. Then Ray and others in 2024, they made resource allocation models to effectively allocate human trafficking detection in resource constrained areas, and think they effectively demonstrated it in Nepal. Then Singh in 2020 used the K-means clustering algorithm on the crime against women data set from National Crime Records Bureau. And Das in 2019 used classification techniques for prediction and analysis of crime in India. So as you can see, machine learning is being used for crime and crime analysis and risk analysis. However, the novelty of our paper is that this has not really been done extensively on the human trafficking data set in India. And there is a very big lack of research in the human trafficking in the Indian context, especially with respect to other types of crimes, such as against women or against children. There's also a need for a multi-dimensional analysis, as there are various categories of human trafficking, and a visualization so actionable steps can be done. And finally, a category-based analysis and population normalized analysis has not been conducted. So this was the novelty of our paper. This was also our objective. So a multi-dimensional risk analysis and also creating risk maps for targeted action so that we can create policy measures that really aim at curbing human trafficking in India. Uh, Getting to our methodology. So this was our workflow for specifically data collection and data cleaning. So we took data from the NCRB website and also some population data from RBI, combined the data and also aggregated it over 2020, 2021, and 2022. Finally, we cleaned the data and basically created 4 data sets depending on the various categories we were analyzing. The data set is, like I said, aggregated over 3 years. And this 3-year window was chosen due to a change in the data storage format by NCRB. So, and also to maintain the applicability of the data, only most recent data was used. And states with no cases of human trafficking were dropped to not skew the classification results. Speaking of the K-means algorithm shortly.
So K-means is a unsupervised type of machine learning algorithm, which basically means that it learns from data without human supervision. So the process of this algorithm, which is what we used, we first decided the number of clusters which we want to use, and then we choose k centroids from the data points randomly. After choosing these centroids, we compute the distance between the centroid and each data point, and with this distance, whichever has the shortest to the centroid, we group it into the k number of clusters which we have originally chosen. And on repeating these steps over several times, once we get consecutively same results, we know that these are the final clusters and we will use these clusters for the final results.
So for our analysis, we used 3 clusters, and those were high, medium, and low risk then. So to our results. As you can see, these are the risk maps that we obtained. And there are quite a few interesting things that can be analyzed from this. So the total number of states that classified as high risk is 7. They are Odisha, Delhi, Telangana, Goa, Rajasthan, Bihar, and Maharashtra. And it's also interesting to note that smaller states like Goa, Assam, and Arunachal Pradesh, and some union territories like Pondicherry get classified as high or medium risk when we analyze cases per lakh population. So we can see Goa is actually highlighted here and Pondicherry also. So this goes to show that how important the population normalized data is. And another visualization we used is the simple scatter plot organized by cluster. And we can clearly see that here in cases per lakh population, how many more new states get classified as high risk, because even for their very low population, they are having a lot of cases relatively. Whereas if we just look at the total number of cases, only Odisha gets classified as high risk. So this shows us some very important details on the dynamics of human trafficking risk in India. Finally, we aggregated our results using a table whereby all the high and medium risk states were summarized, and we ranked it based on cumulative risk, where a high risk classification was weighed double as much as a medium risk classification, just as a basic ranking. So we can use this, for example, to allocate human trafficking resources based on this priority order. So I'll come to the conclusion now. As I was saying, we have compiled a ranked list of Indian states at the highest risk for human trafficking from a multidimensional perspective. So through various categories, I would just like to show that again. We can see the total cases per lakh population, only for sexual exploitation and forced marriage, child trafficking, and forced labor, which are all having very different causes. They have been aggregated together in this table. Through this table, we could use appropriate allocation of anti-human trafficking resources such as anti-human trafficking units, and also perhaps a possible allocation strategy for a nuanced risk by category. We have also visualized our findings through risk map of India, marking high, medium states in red and orange. So this analysis is to understand further on as further scope. We can also analyze the underlying causes behind risk classification, and the results suggest our analysis will be most useful if done separately by cause of human trafficking and using population normalized data, because clearly there is a big influence and very big difference based on the category. Finally, these are our references. Thank you so much for listening, and if you have any questions, please let me know.
So thank you for the presentation. So it's a nice presentation. So now it is open for question and answer session. So if anyone wants to ask or want to learn something, then please proceed. So participants, so if you want to ask any question, please proceed. Okay, so I have one or two question. First one is, how do you obtain the data set? Because I think it's very difficult to, it's a tedious task to obtain data
So
sets.
yes, so actually these data sets are available on the National Crime Records Bureau website as Excel sheets to be downloaded. So as I was saying, they actually changed the format in 2020. So, but since then, the format has been the same. So it was quite easy to aggregate that way. And the data is openly available.
Okay, so next question is, how do you clean the data?
Yes, sir. So for that, if you see our data cleaning, there was not much cleaning required. Mostly, we wanted to drop the states with no cases, and as also not only by total cases but also by cases by category. So that was mostly the cleaning that we needed to do. There's no redundancies per se, so that was mostly it.
Okay. Thank you.
Thank you.
So now we'll move to the next presentation. That is paper ID 734 from Srimanti Roy Chaudhary. So are you there? Yes, Srimanti Roy Chaudhary or Javed Sahriyar. Okay, fine. Otherwise, we'll move to the next presentation. Paper ID 735. Amina.
Yes, sir.
Yeah. So please proceed with your presentation.
Good morning, all. I am Amina from College of Engineering, Trivandrum, and I'm going to take a presentation on topic torque control of dual three-phase PMSFs. These are the contents: introduction, literature review, objective,
Amina,
methodology, research.
sorry
Yes,
for
sir.
the interruption. I think your screen is not visible. It's not moving. I think you are presenting through your phone, mobile phone.
Yes, sir.
I think it's not visible.
It's visible, sir.
No, still not visible. You can stop sharing, then again please share your screen.
Okay, sir. Sir, is it visible?
No, it's still not visible. So otherwise, we'll do one thing. You try to sort it out. What is the issue?
No.
We'll move to the next presentation. Is it fine, Amina? Yes, Amina. Okay. Next, Prabhu Kumar.
Yes, sir. Can I share
Are
my
you
screen,
there?
sir?
No, please share your screen. Amina,
Yeah,
please.
okay, sir.
Hello, Amina. Stop sharing your screen. Prabhu Kumar?
Hi, sir. Can I share my screen, sir?
Yes, please share your screen. Let's see.
Okay, sir. Okay, sir.
Yes, Prabhu
Yeah,
Kumar.
okay, sir. I will join
Yeah,
with my
Amina.
PC.
Yes, Amina. Just after Prabhu Kumar, you please join. Okay, you try to sort it out. What is the issue? Otherwise, at the end
Sir, is
we
it
can
visible?
see.
Sir.
Okay, Amina. I think
Okay,
your
sir.
network issue, some network issue is there, I think, for you.
Okay, sir.
So after this presentation, after Prabhu Kumar presentation, then please try to join. Okay. So yes, Prabhu Kumar, your paper ID 737. Is it right? Prabhu Kumar? Yes, 737.
Is it visible?
Yes, so please proceed. So you have maximum 15 minutes, okay? So within
Follow?
that, try to wind
Yes,
up.
sir.
Yes, please proceed, Prabhu Kumar.
So coming to design of 4-port MIMO antenna, 5G sub-6 GHz applications. So these are the contents of my paper: introduction, literature
So,
survey, objectives,
yeah,
methodology, and
Prabhu Kumar.
novelty.
Prabhu Kumar, sorry for the
Sir.
interruption. Please make it presentation mode. See the bottom line. There will be some screen type. Full screen. Make it full screen.
Yes, sir.
Yes. Now please proceed.
Yes.
Please proceed, Prabhu Kumar.
And seamless connectivity, latency, and vast number of devices are connected. This is essential for Internet of Things, used for Internet of Things. So to meet these 5G requirements like high-speed internet, seamless connectivity, and support vast number of connected devices, we need a antenna. So the best antenna which is suitable for this 5G network is MIMO antenna, multiple input and multiple output antennas. So these MIMO antennas plays key role in 5G networks because of they increase the capacity and reliability of wireless communication by multiple antennas at both transmitter and receiver. Will improve the spectral efficiency and allow the more data to above 6 GHz band. Advantage is the below 6 GHz band, like improved coverage.
Prabhu Kumar,
in
your
band.
voice is
In
breaking.
India, mostly by so in India, we are using mostly 3.2 to 3.8 gigahertz band. So coming to the literature survey, this is the literature survey. So there are some techniques involved to decouple, use it to enhance the performance of the MIMO antenna. So the main problem in MIMO antenna is isolation enhancement between the antenna elements. So this isolation enhancement can be done with different metamaterials, self-isolation, electromagnetic metamaterials. Okay, EBG structures are used to improve the performance of the MIMO antenna. So this is the literature survey. And coming to objectives of my paper, design of orthogonally spaced MIMO antenna for 5G, sub-6 GHz applications, and also to achieve the good bandwidth and to to good bandwidth, we are incorporate a DGS and ground stubs are used to minimize the mutual coupling between the antenna elements. And also we can improve the EC, DZ, torque and CCL of the MIMO antenna parameters. And this is suitable for 5G. Coming to methodology and novelty, so we are using an orthogonally spaced elemental arrangement. So this provides the better isolation characteristics. So the antenna elements are arranged orthogonally. So this provides better isolation enhancement. So coming to another advantage is the design includes ground stubs and defected ground structures, which is used to reduce the mutual coupling between the antenna elements. And coming to resultant discussion, so here the antenna is designed using FR4 material with a distance of 4.4 and a height of 1.6. So this is single antenna. Here it is single antenna. So here we are using two slits and a parasitic element. These are used to improve the impedance matching, used to improve the impedance matching, and also used for shifting the frequency from higher band to lower bands. So we are operating the antenna at 3.2 to 3.8 gigahertz band because we are operating the antenna at lower sub 6 gigahertz band. In lower sub 6 gigahertz, in India, we are mostly using 3.2 to 3.8 band. So I am focusing on 3.2 to 3.8 band only. So for single antenna designing, for the gigahertz. So this is single antenna. So the dimensions of the single antenna is 23 mm by 30 mm. So coming to two element antenna design, so single element can be used to improve into two element antenna design. So here the two elements are arranged orthogonally. So antenna 1 and antenna 2 both are arranged orthogonally. This can improve the antenna performance. Be resonated 3.5 gigahertz band with a bandwidth of 3.2 to 3.86 gigahertz band. So and the blue line, it is indicated that it is the isolation S21 and S12. S21 and S12 dB, 10 dB, entire within the overall band. So it is good isolation. So minimum so coming to proposed here moving into MIMO antenna diversity characteristics. Okay. And hence the isolation between the two elements. Isolation between the two elements. So the antenna will be resonated at is the four antenna S11, S22, S33, S44. So the four antennas are resonating at the same frequency band, that is 3.08 to 4.4 gigahertz. We are operating the antenna at 3.2 to 3.8, but I got the antenna bandwidth at 3.08 to 4.41. Time element between the antenna below minus 15 dB. So the can get the isolation below the minus 15 dB only. Next, we're moving to the antenna. The gain of the and frequency of 3.6 GHz. So these are the MIMO antenna diversity parameters. Control of correlation coefficient. So I'm writing the ECC 12, 13, 14. So antennas are correlated to each other. ECC describes that how the signal from multiple antennas are correlated. Efficiency of the spectrum and capacity of the spectrum also. Diversity gain. Okay, so ECC and diversity gain are
Prabhu Kumar, you are
ability
running
of the
behind
antenna to improve
time.
the signal.
You are running behind time, so conclude quickly.
I said. So coming to the conclusion, the we have computed MIMO diversity parameters like CCL and DZ and DCC. So the antenna, so this antenna is MIMO antenna. That's it. These are the references. Thank you, sir.
So, so any question from the participant? Please free to ask.
If you're having any doubts, please ask me.
Okay, Prabhu Kumar, so you have placed two antenna in orthogonal, right? So you said that it will improve the performance. I mean, what is the physical significance of placing two orthogonal? Two antenna in orthogonal. How do you say the performance will improve?
Will increase the as compared to the other other techniques.
Okay. Thank you, Prabhu Kumar. Thank you.
Thank you, sir.
So thank you. Please stop sharing your screen. So next,
Yes.
okay. So Amina,
Yes, sir.
yeah, please proceed with your presentation.
Is it
Yes,
visible,
now it
sir?
is visible. Please make presentation mode.
Okay, good morning, all. I am
Yes, so please
myself
note that you have
Amina.
15 minutes.
Okay.
Okay, continue.
Myself Amina from College of Engineering Trivandrum. I am going to take a presentation on topic torque control of dual three-phase PMSMs and next going to the contents, introduction, literature review, objective, methodology, results and discussion, conclusion. And now going to the introductions. With the increasing global traditional energy, the permanent magnetic synchronous motor is
So
widely used.
Amina, I'm stopping you. So please make it presentation mode.
It's presentation mode, sir.
No, it is not in full view. That point.
Okay, sir. Now going to introductions. With the increasing global traditional energy, the permanent magnetic synchronous motor is widely used in electric vehicle and other fields because of its advantages of high efficiency and high power density. In order to enhance high reliability, lower torque ripple, high power rating, multi-phase PMSMs are used. The dual three-phase PMSMs is an advanced motor configuration that uses two sets of three-phase windings spatially shifted by 30 degrees and whose neutral points are separated. I'm now going to literature review and first paper, the maximum torque optimization control of dual three-phase PMSM in low frequency and static operation. In that paper, there is an advanced control strategies to maximize torque output efficiency and reliability of dual three-phase
Your
PMSMs.
slide is not moving, Amina. Sorry for the interruption. Your slide is not moving.
It's moving, sir. Is it visible, sir?
No, it's still in the introduction. Now, yes. Please make it in PowerPoint mode. I mean, presentation mode.
Yes, sir.
From the current slide.
Is it visible, sir?
No, it is visible, but not in the presentation mode. Click that from current slide. Top you see, top left.
Is it visible, sir?
Okay, you continue, please. Continue.
From literature review, the maximum torque optimization control of dual three-phase PMSM is low frequency and static operation. In that paper, there is an advanced control strategies to maximize torque output efficiency and reliability of dual three-phase PMSMs during low frequency and static operation. And next, the fault-tolerant control of dual three-phase PMSM machines drives under open phase fault. In this paper, it only minimizes the copper loss and is restricted to high-frequency operation. And the next one is the dual three-phase PMSM torque modeling and maximum torque per peak current control through optimized harmonic current injection. In this paper, the maximum torque per peak control is applicable for high torque applications. Now going to the objective, that is to design a torque controller for a dual three-phase PMSM. I'm now going to methodologies. The methodologies used for obtaining the objectives are mathematical modeling of dual three-phase PMSM and modeling of the torque controller of six-phase PMSM, and the next one is performance analysis. And the first one is the open loop simulation of a.
Amina, your slide is not moving. Your methodology. I think you have, poor connectivity maybe. That is the issue.
Yes.
Now it is visible. So while doing that, you please click that slide, okay, so that it will be visible to all of us.
Okay, sir.
Okay, continue.
And the next one is methodologies. The methodologies used for obtaining the objectives are mathematical modeling of dual three-phase PMSMs, modeling the torque controller of six-phase PMSM, and next one is performance analysis. And now going to the simulation. Open loop simulation of dual three-phase PMSM is done by using MATLAB Simulate. From this simulation block diagram, for a six-phase PMSM, we can use two sets of three-phase PMSMs. For using two sets of three-phase PMSM, we consist of two sets of voltage equation. By using the mathematical modeling equations, we get an voltage equation VD1 is equal to RDID1 minus omega LQ1 IQ1 plus d by dt of LD1 ID1, and also VQ1 RQ IQ1 plus omega R into LD1 ID1 plus d by dt of LQ1 IQ1, and also VD2 RD2 ID2 minus omega R into LQ2 IQ2 plus d by dt of LD2 ID2, and also VQ2 equal to RQ IQ2 plus omega R into LD2 ID2 plus d by dt of LQ2 IQ2. From this mathematical equation, we can use this simulation block diagram. From that, we get results. Here we get a torque versus time graph of an open loop dual three-phase PMSM. Here, for a no load, we get a torque versus time graph. And next one, For a load of 205 Newton meter, we get a torque versus time graph. Here we get a torque ripple of 60%. And this one is the speed versus time graph of an open loop dual three-phase PMSM. Here we get an open loop speed of 1500 RPM. Now we are going to the torque control of dual three-phase PMSMs. Here for an asymmetrical dual three-phase PMSM has a two sets of three-phase winding with separate neutral points, and the systems are displaced by an angle of 30 degree. There are 6 currents IA, IB, IC, IX, IY and IZ. This is the controller block. This controller block consists of an current IA, IB, IC, IX, IY, IZ. These currents are given to the current controller. The output of the current controller consists of two sets of DQ to ABC transformation blocks. These blocks contains two separate three-phase output. There are separate three-phase output are given to the SVPWM block. The output signals from the SVPWMs are provided to the inverter 1 and 2. These are used for the modulating these inverters. The output of these inverters are then given to the 6-phase PMSM. And the results of the torque control of dual three-phase PMSM. Here this is the torque versus time graph. Here the torque is applied as a step input at different loaded condition, and the percentage torque ripple is varied from each step input. Here for a maximum torque of 205 Newton meter, the torque ripple is reduced as torque ripple has a minimum value of 9.75. Here we give a different step values. For a 150 Newton meter, the torque ripple is from 80%. For 100 Newton meter, the torque ripple is from 30%. For a 60 Newton meter, the torque ripple is reduced from 50%. For a maximum values 205 Newton meter, the torque ripple is reduced as 9.75 Newton meter. This is the current waveform, current versus time graph. As per step input, current varies like this. From the result analysis, the percentage torque ripple is reduced from 60% to 9.75%. That is, from open loop, we get a torque ripple of 60%, and now we get by using the torque controller method, we reduces the torque ripple from 9.75%. And now going to conclusion, the torque control of dual three-phase PMSM presents a promising avenue for enhancing motor performance in demanding applications. The combination of advanced control technologies and inherent advantages of dual three-phase configurations offer a compelling solution for modern electric motor types. The torque management of dual three-phase PMSM is main part of this portion. It is essential to have an effective and dependable torque management for the proper functioning of this machine. The modeling and the simulation of open loop control of dual three-phase PMSMs with 6-leg inverter is performed. The controller scheme is proposed to enhance the torque output capacity of dual three-phase PMSM by considerably reducing torque ripple from 60% to 9.75%. And these are the references. Thank you.
Okay, so thank you for your presentation. So any question from the participants?
Yes, sir, I have one question.
Yes, please proceed.
Is there any control technique for this dual PMSM control except DTC?
Here we use a torque controller. Here we use a simple PI controller method in this torque control of simulation. We only use in online simulation MATLAB.
Okay. Do you know any other control technique except DTC?
As we can use field-oriented control and any other control techniques we can use for dual three-phase PMSM.
Okay, thank you.
Any other question from the participant? Okay, so can you tell why your torque ripple is more in open loop? You see your first figure, I think, most probably. There is
Yes,
more
sir.
chattering, right? In torque.
Uh,
Yes.
Yes, sir. By using mathematical modeling equation for open loop, we get more torque
Please
ripple.
click that slide. Yes. 2 question here. Chattering is much more fine. Here you are not using torque control, I think. Second
sir.
is why the mean value is 0.
At zero, no load. At no load, this is the torque ripple. For a maximum value, we get torque ripple 60% or more.
So here also is it in open loop? Sorry, loaded condition or on-load condition?
Yes, loaded conditions, sir.
Loaded condition also, if you find the mean, maybe okay. Okay. Thank you.
Thank you, sir.
So who is your next? So no, sorry. Which one?
738.
Paper ID 738. Abhismith. Abhismith Datta.
Yes, sir.
Yes. So your topic will be extended high boost quasi jet source inverter consisting an active switch, right?
Yes, sir.
Okay.
So may I
Please,
share?
please. Yes. Please share your screen.
Yes. Am I visible, sir?
Not yet. I mean, your screen, you are visible.
Okay. Let's. I think it's maybe one problem is occurring, sir. Sir, give me, sir, just 1 minute, okay, sir?
Okay.
Yeah. Sir, is that visible, my screen?
Yes. Now it is visible. So make it presentation mode.
Okay. Okay, good morning, sir. My name is Abhishmit Datta. I'm doing my PhD under Dr. Aravind Panda sir at NIT Sikkim, and I'm going to present one paper. Name is the Extended High Boost Quasi Jet Source Inverter consisting an active switch, whose short form is EHV QZSI.
So
These are my
Abhismith,
contents.
sorry for
Yeah,
the
gee.
interruption. It's not
Yes,
yet
sir.
in presentation mode.
Uh,
Please make it to presentation mode. Your slide is visible, but not in presentation mode.
Now it is presentation mode, sir.
Just do it. Not yet.
Now.
No. I'm able to see your screen, your
Sir,
slide,
actually,
but not in the.
in my screen, it is, sir, in the full screen mode and in the presentation mode.
In the presentation mode. Okay.
Yeah,
Okay, then
yes,
continue.
in my
Then
screen.
continue.
Okay. Thank you, sir. Some maybe some technical error is taking place, so that I can't do that thing. Okay, sir. So these are my content and the introduction section. So we know that the DC to AC converter is a widely used for the various application device. We can use this kind of device like that means the inverter we can use in the PV grid systems or in the electric vehicles or in the any kind of the renewable energy source like the wind or wind energy conversion system or anything. But the main disadvantage of the DC to AC converter is we need a extra components, extra power converter, which is the DC to DC converter, so that we can step up the DC voltage level. Okay, so that's why due to increase the efficiency of the systems or do our system work properly, we need this extra power converter.
Okay,
And this
obviously,
is one.
sorry for the interruption.
Yes, sir.
You just
Yes, sir.
move your slide. Let's see. Move your slide.
Yes, sir.
I'm unable
I'm
to see
moving,
your
sir.
slide.
Sir, now you are able to see, sir?
No, it's the only introduction part. Yes, now it is visible. Yes, now it is moving.
Okay, sir. Now, sir, can you just say that now it is visible, sir? I am now in the
In the
introduction section.
literature review, yeah, introduction. Yes.
Yes, sir. Yes, sir. So may I
Okay.
start, sir?
Yes, yes, please,
Yeah.
please.
Yeah, so in the introduction section, I just want to say that the DC to AC converter, that is the inverter we are used in a various applications like PV model systems, like electric vehicle applications, or any kind of energy conversion systems. But major drawback of the inverter is we cannot step up the DC bus voltage level to the system, because we need to step up the system to increase the efficiency or mitigate some limitations. So that's why we need one extra converter, that is the DC-DC converter we have to use. So that's why the system is going to work as a two-stage system. So in the literature review, we found that instead of using these two converter, that is one DC-DC converter and one DC to AC converter, we can use one single converter, that is the jet source converter. So in the jet source converter, the main advantage is it's will act as a single source systems, and as per the change of the topology, we can get a very promisable gain, which is more than the DC to DC converter. So that's why we are working to make a different topologies, so that the gain and the other factors of the DC to AC converter can be improved. So that's why our main objective is to design and develop a switch inductor base, that is one classifications of jet source inverter, to make one QZSI topology, that is the quasi jet source inverter topology, to obtain the high voltage gain, low voltage stress or low stress on the component. That means somehow whatever the components we are using, we want to make less stress components, the optimal number of the switch inductor to reduce the weight, and make a compressed model, so that our system can give the more gain with in a less weight. So to do so, we make one novel topology, which whose name we suggested as the extended high boost quasi jet source inverter, where one active switch is being present. So our name is as a consisting of an active switch, that is the EHB QZSI. Here you can see that there is a three inductors, 7 diodes, and 4 capacitors. So this is the overall schematic diagram of our device. So as we all know that the JDSI topology will work in a two stage, and one is the shoot-through state, another is the non-shoot-through state. In the shoot-through state, what will happen? The two switch of a particular leg will be short-circuited. So here we suggested in that particular simulation, in the schematic diagram, that there is a circuit in the inverter side is being short-circuited, and the switch is going to be act as an active switch. And here D2, D6 and D5 are in is a reverse bias, so it is in the open circuit. And if we apply some KVL and KCL, we found that some voltage and current equation we got in that particular state. Okay. And after that, if we apply the non-shoot-through state, that is the active state we can suggest, and we got this kind of symmetric figure, where we can say that here the diode D7 and D7 are in the reverse bias, and the current will flow in the particular directions. We got some voltage, inductor voltage and capacitor current. And if we apply some voltage second balance equation, and we got the boosting factor as 2 into 1 plus d divided by 1 minus d minus 2d square. This is a promisable boosting factor we got, where d is the shoot through. Whatever the shoot through, that means the short circuit stage we are applying. So this kind of boosting factor we got. And after that, we calculate the parasitic value, that means the inductor and current, inductor and capacitor design we have done, and we got this kind of value. And this is our system parameter. In that particular, for this paperwork, we use the MATLAB simulation environment, and here we use the as per the design of the L and C, we implemented this value, and we use the 5 kilohertz frequency. And we got some input voltage and output voltage. Here in the VDC voltage, we applied some 40 volt, and as a output we got the approx 200 volt. That is the near about the 5 times, near about 5 times voltage gain we got. And here you can see the output voltage, that is the VDC. It is known as the VDC or VPN. So sorry, this is the VPN. We suggesting VPN is going to be same as the summation of the C4 and C5. Same thing we will get in that particular capacitor voltage trace. That is this is the C3 and C4, and we just multiplied with the 2, we got the output voltage level. And these are the inductor currents, where in the Shuddha state the inductor current is going to be step up, and in the non-Shuddha state it is going to be step down. And this is the VPN voltage we got. It is near about 200 volt. And this is the efficiency curve of the overall systems, and we take the duty ratio, that is the Shuddha state, from 0 to 0.17, and we got this kind of curve. And this is the comparison table. Okay, so this is the comparison table of the existing papers, existing recent literature review I have done, and we got this kind of value, and we got that the boosting factor is very high as compared to other topologies. Like here I mentioned this kind of name. Here the boosting factor is very good. The voltage trace, the capacitor stress, you can say the voltage stress in the capacitor across the capacitor is very is low as compared to other device, because we just multiplied, here we just sorry, yeah, we just multiply our overall voltage into the two capacitors, so that's why the voltage stress will be reduced. And the third one is, sorry, yeah, and the third one is the current stress. So this kind of the comparison topology we have done. And in the conclusion and the future work, we can say that yes, our topology provides the good voltage gain compared to the other topologies, and it has used 2 less component than the UGHQZSI. That is a one published paper. It used the less than 2 components. And in the future works, our main intention is to get more more boosting factors as compared to the others existing topology, and we just try to make the less component as compared to whatever we are used. So these are the reference, and thank you.
So any question from the participant? So I have 2 questions. One is regarding your
Yes.
efficiency curve, then how do you plot
Yes.
that curve? And second one, that you talked about voltage trace, right? So is it related to that voltage peak or yeah, voltage peak on the capacitor?
Yes, sir. So first questions, if we see, just going to this, yeah. If we see the overall diagram, there is a 3 component, right? One is the inductor, diode, and capacitor. For the inductor, there is a loss, that is the I square R loss. So we take the inductor current, the RMS inductor value of the current. This is a very rigorous process to find the efficiency, and the RMS current of the inductor, and we just estimated the parasitic resistance value like 0.01 or 0.02 ohm, and we just multiplied with that, so that we get some drop in the inductor. And for the diode, there is a 2 type of loss. One is the forward biasing loss, and another is the copper loss. For forward biasing loss, there is a equation is called the IDF, that is the average voltage, D average into the VDF. There is a forward biasing voltage. If we multiply this, then we got the forward biasing loss. And the same, and we also estimated the RMS value of the diode, and we multiplied with the parasitic resistance value of the diode, so that we got this kind of value. And same as the capacitor, we estimated the RMS value the capacitor and multiplied with the parasitic amount of the resistance. And for the switching loss, there is a two types of loss we estimated. One is the inverter loss, that is the normal copper loss type of state, and another is the inverter switching loss. So this kind of all loss we combine, and we know the power value because we all know, so that we use the power output divided by power output plus all those particular laws whatever is happening in our parasitic element, and we just additive all those device, and we got this kind of this kind of value, like the efficiency we got. Okay, so am I clear to you, sir?
Yes, yes, yes. Thank you.
Okay, and the second one is the voltage trace. Voltage trace is nothing but the voltage appeared across the capacitor. So if the voltage will not divide it into the two capacitor, then what will happen? The voltage trace will be very high. So here in our topology, the voltage will be divided into two capacitors. So the voltage is going to be reduced, going to be mitigated as compared to the other extrinsic capacitor.
So, okay, Abhi Smith, it's a nice presentation and nice
Thank you, sir.
topic.
Nice, thank
So,
you,
okay,
sir.
then stop sharing your screen.
Yes, sir.
Next, 739. Huh? So, next is paper ID 739, Gautam Kumar.
Yes, sir. Good afternoon, sir.
Yes, good afternoon. So, you will talk regarding modeling of electric vehicle and its component on MATLAB or Simulink, right?
Yes, sir. Is my presentation
Yes.
visible, sir?
Yes, yes, it is visible. So, please proceed.
Okay. I am Ashish Raj, and I'll be presenting the conference paper on the topic modeling of electric vehicle and its component on MATLAB Simulink. This will be the flow of my presentation. Coming to the introduction part, if you are talking about EV, then EV offers a superior performance and cost saving, but also facilitate renewable energy utilization and grid optimization. And if the EV, the existence of if the existence of EV, then the next big thing will be the charging infrastructure of the EV. The onboard chargers are typically integrated system within the vehicle, converting AC current from the grid into the DC current necessary for the battery charging. And off-board charger utilizes external charging system with the AC DC conversion occurring within the charging station itself. After the introduction, the road load calculation, in the equation A, we have calculated the aerodynamic drag force. Equation B, rolling resistance force. Equation C, uphill resistance force, and equation D is accelerating force. Then the road load calculation is calculated within the MATLAB Simulink itself using the math operators. This is the dynamic model of electric vehicle. The force acting on the vehicle are aerodynamic force, rolling resistance force, gradient force, accelerating force, and differential equation to calculate these forces are m dv by dt is equals to fx minus fd minus mg into sine beta. Beta is the angle between the fx and fd. This is the MATLAB Simulink model for the dynamic model of EV. And this is the complete model for electric motor with the vehicle body, where the mass of the vehicle is considered at 1800 kilovolt, front area 2.91 meter square, and so on. This shows the battery management of EV, which also increases the overall life of the battery, lithium-ion battery, and the performance of lithium-ion battery, and also protect the battery from under voltage and over voltage. This is the EV modeling using signal library, where the no load speed of the EV is 10,000 RPM. Rated speed is 3796 RPM. Rated load is 84 kilowatt. Rated DC supply voltage is to 320 volt, and rest the dimension and the electric vehicle, the dimension of the electric vehicle are same. Then here here we have given a reference velocity input to the MATLAB, and we have compared the same with the actual velocity, and the appearance of the reference velocity and actual velocity seems to be same, and the figure also shows the SOC curve for the lithium ion battery. This table shows the calculation result for the road loads yielded in the following results: aerodynamic force, that is 323.2 Newton, and so on. The following results are in line with the battery pack calculation. Total energy consumed per kilometer is 185.5 watt-hour per kilometer. Total driving range is 250 kilometer. Depth of discharge 85%. Number of cells in series is 100. Number of cells in parallel is 11. Battery pack weight 297 kgs. Coming to the conclusion, our project initiates with an in-depth analysis of road load calculation, crucial for understanding the force exerted on the electric vehicle during the operation. When the delay into the power electronic converter, the essential components facilitates the seamless transition of electric propulsion. Our project also examines the intricacies of battery pack calculation. Our innovation contribution lies in the dynamic mathematical modeling of EV, essential in our understanding of EV dynamics. Leaving MATLAB Simulink library, we present a comprehensive modeling framework. Finally, our project cumulates with the implementation of passive cell balancing along with over voltage and under voltage protection mechanism. These are the references. Thank you for listening.
So any question from the participant? Yes, any question? Okay, so thank you, Gautam. It's a nice presentation. So
Thank you, sir.
yeah, so next we'll proceed. Paper ID 741. Astha Singh.
Yes, yes.
Yes. So your
Yes,
topic is performance analysis between fuzzy logic and PI controller in DC-DC boost converter.
yes.
So please share your screen and proceed.
Okay. So my screen is visible.
Yes, it is visible. Make it do presentation mode.
Okay.
Control L. It's PDF, right? Control L.
Okay, controller. No.
No, on the screen, you click on the screen and press Control L. On the screen, yes.
Yes, here only.
On the PDF,
Hmm.
you click on the PDF and Control L. Okay, continue.
Okay. So, good morning, everyone. I am Asa Singh, and my paper ID is 741. Today I'll represent my paper, and the paper topic is performance analysis between fuzzy logic controller and PI controller in DC-DC boost converter. So, for this, these are my contents, what I will show you here in the presentation. And this is the introduction where I have defined what is the importance of SMPS, and we use this SMPS mode for increasing the efficiency of the DC-DC converter, so that because that our if we go with the passive device, using passive device, there would be very much lower efficiency at the output if we go for buck or boost and or anything else. But in SMPS mode we can utilize using LC. So for designing the boost convert for designing the controller part, here is the fuzzy logic controller and PI controller. For the fuzzy logic controller, The key concepts are fuzzification, rule-based, interface engine, and defuzzification. So here there are two inputs. Fuzzy logic takes error and change in error, and that too is based on a particular table that is predefined. And this fuzzy logic controller is handles the non-linearity, and that's why it is used in complex systems and non-linear systems. Whereas for PI controller, we have to do mathematical modeling to get the value of proportional and integral values, doing uh, mathematical following the mathematical equations, where we follow the closed loop feedback and calculate the calculate the values based on the input and output and the value of LC. It is easy to design, but it would be, and the disadvantage is it can be less effective in for the complex and non-linear systems. So the basic objective of my paper is to design a closed loop DC-DC converter. And for closed loop system, I used PI controller and fuzzy logic controller in MATLAB, and will compare its result such as peak overshoot, RMS value, power, and efficiency. So first, this is open loop boost converter, where a few assumptions are made, like the system is stable and all parts are perfect. And for calculating the LC part, I took the value of VS12 input voltage as 12 volts and output voltage as 24 volts, where the deviation in ripple current is 5%, and ripple voltage is also 5%. And through that, we can calculate the value of inductor and capacitor for it. So following that, this is the table rule for fuzzy logic controller, which I have implemented in MATLAB. So here we can check this is a error graph. This is change in error graph, and duty ratio would be the output of this fuzzy logic controller. So for simulation part, I did in Simulink, and where I use this builder to make a variation in the input voltage to track if how efficiently and quick and dynamically the controller is controlling the output voltage. So for that, I made this random little. So here I have taken the resistance and as 100 ohms, and here we can see the capacitance is 15 microfarad and inductance is 12 milli Henry. So for that, if we go by calculation, the KPKI value would be 0.01 and 50. So this is the output result, output voltage at 100 ohms. And this is the FFT analysis of output voltage for 1 hertz. As the FFT analysis could not be done for 0 hertz, so I put here 1 hertz. So as we can see here, there's many very much ripple in output voltage, and and the FFT analysis also shows like like there is very much contents of different frequency also present in the output. So from that, we have calculated the peak overshoot, that is 121%, and the RMS voltage is 26.6, which is a little higher what we expected as 24 volts. and also the voltage ripple is 47.8%, and THD at with respect to 1 Hertz is 36.68%. This is the result with a fuzzy logic controller. Here also the same parameters I have taken, such as filter capacitance as 50 microfarad and filter inductance as 20 millihenry. But as we can see that here in the output voltage, the ripple is much lesser as compared to what we see in the PI controller. And for FFT analysis, if we see, we are getting very much components of different frequencies as we were getting in the PI controller. So peak overshoot is also very lesser as compared to PI, and the RMS is also greater than what we expected, but this is the one disadvantage I observed in between PI and FLC, whereas in terms of power, the FLC is giving more power, output power, and THD is also lesser, and voltage ripple is also 28%, which is lesser than the PI controller. So this is my conclusion part, where I have mentioned what are the improvement parts, improvement parameter that we get using FLC controller, then a PI controller, and the future scope of FLC could be the area where we are using non-linear and complex systems, or some predefined controllers we need. So those area we can use FLC controllers. These are the references I got help from. Yeah, that's the presentation
So
part from.
any question from the participant? Any question from the participant? So Astha, I have one question. You said that fuzzy logic will handle nonlinearity. Can you elaborate? I mean, how it will handle nonlinearity?
So for that thing, here I have already showed you. There is a predefined set of rules which it will follow. So no matter what change we face in the change of parameters and all, we will the output would be based on these set of rules. As we can see, the
So that
main.
means it will not depend on the model, right?
Yes.
Yes.
So
Okay.
okay.
Okay. Thank you for the presentation, Astha. Okay.
Okay.
So
Thank
now
you.
we'll move to next presentation. Paper ID 743. Anyone? Rahul Pal?
Yes, sir. Yes, sir.
Yes. So your topic is novel low PDP CMOS double base comparator, right?
Yes, sir.
So please proceed.
Is this visible, sir?
Not yet. Yes, it is visible now. So make it to presentation mode.
Okay, sir. Is it visible, sir?
No, still not. I mean, your slide is visible, not in presentation mode.
Okay, I get it in presentation mode.
Okay, it is. Please start. Please make sure that you click on that slide so that it will be visible to all. Okay.
Okay, sir.
Yes, please.
Good afternoon, sir. Myself Rahul Pal. I want to give my paper novel low PTP CMOS double base comparator, and this is the content of the presentation: introduction, literature survey, proposed novel low power double base comparator, design and validation, result and discussion, next conclusion, future works and references. Introduction. Actually,
So please, Rahul,
depending-
sorry for the interruption. Please click on that introduction slide so that, I mean, your slide is not moving.
Okay, sir, this is the introduction slide, sir.
No, it's not visible. I mean, I am able to see your first slide only. Yes, now it is visible.
Okay.
Move to second
Okay.
slide, please. Move to
Visible,
second
sir?
slide. No, no, no. Please click on that. Yes, now it is visible. Yes. Okay, in that way you proceed. Okay,
Okay,
okay.
sir. Actually, depending on the demand of portable sophisticated device, there are many challenges in digital system design is a low power solution. So, and for digital comparator also, digital comparator is also one of the major element and to process digital data processing. And the main disadvantage of the binary number system is the carry propagation. Due to the long carry propagation change, the delay is increasing. That's why this at present time the binary number system is less values. To cooperate in this portable and sophisticated device, double-based number system can offer the redundancy, and redundancy that means it can associate with the parallelism, and that can use as a parallel processing. This make double-based is a candidate to choice, reduce the carry propagation and according to the into the operating suite. Due to the property of the redundancy and redundancy, we design this work on novel low PDP CMOS double-based comparator is proposed. And this is the literature survey. In literature survey, there are various circuits designed in double-based mode. First is double-based integer encoder using flash ADC, and second is the double-based parallel addition. That means parallel addition will be done in double-based number system. The third is the multi-based number representation, multi-based number system, and its advantage. And number 4, the proposed comparator is compared with this high speed low power 4-bit comparator using FG-SMOS. And this is the proposed novel-based low PDP double-based comparator. Mainly, first two double-based numbers are there, and we can compare these two values that the value is greater than, less than, or equal. Due to this, all the bits, all the double-based bits are firstly complement inverted. After that, next is the bit digit-wise parallel comparison. That means each LSB to MSB, each bit is compared, and depending on the comparison, higher, greater than, less than, or equal is calculated. And lastly, we are proposed a logic for double-based comparison. Get the output that the value is greater than, or less than, or equal. And this is the first step on inverting the input coefficient. Next, second step is the digit-wise parallel comparison. In this comparison, mainly depending on the comparison, we are getting the greater than, less than, and first is F11G, that means greater than value. If it is greater than, then its value will be 1, and remaining less than or equal is will 0. If the bit value is equal, then the F11 equal E, that value will be 1, and the remaining are 0. And if it is less, then F11L less value will be 1, and remaining that two equations are 0. In this way, we can compare the digit bitwise. And lastly, we use final logic for the double-based comparison. This is the truth table. Here you can show that first is the input A coefficient, and second double-based number is input B coefficient and the result. Depending on the value of the input A and input B, the value is calculated and then the result will be in result part. If the input A is greater than input B, then greater than A greater than B equals to 1. If it is equal, then A equals to B equal to 1. And if it is less, then A less than B equals to 1. In this way, we draw the truth table. And depending on this truth table, we can calculate the equation. These are the final equations. After that, we calculation, we can get the output and design the circuit. This is the circuit of the double-based comparator. In this resultant discussion, we can show the first table. We proposed a double-based comparator. Here the device count is 294 and delay in picosecond is 163. Average power in microwatt in 500 megahertz frequency there are 592, and PDP will be 0.96 into 10 minus 3. To compare this result, we can compare with some existing paper on binary and ternary, binary number system and ternary number system, and there is so that the power is less and in compared to the previous one. Conclusion: in this work, we proposed a low power double-based comparator using traditional CMOS logic. Idea and validation is designed using 32 nanometer standard CMOS technology and using 0.9 volt power supply. And power response of the proposed double-based comparator circuit is compared with the most relevant counterpart with equal operating frequency as a benchmark studies. In future scope, design of higher double-based comparators circuit will be added with added scalability. That means we want to here we propose 2x2 double-based comparator. In future, we are trying to propose a higher order double-based comparator and apply. Second feature scope is the apply proposed idea can be used to exploit the advantage of double-based system for high efficient system design. This double-based comparator, applying this double-based idea, we can use in high efficient system. This is the these are the references. Thank you.
So any question from the participant? Okay, so Rahul, I have one question. So is this your, I mean, the approach you have simulated or you have experiment?
Yes.
It's a simulated one, right? Okay. So you are planning for, acha, okay. So further you are planning for any experimental validation in future?
Yes, sir.
Okay. So thank you, Rahul. It's a nice presentation and nice topic. So may I ask you, all of you, please, can you please on your camera so that we can have a screenshot for this session?
Sir, my paper is bending, sir. I'm not present at
Sorry, which? Oh, paper ID 734.
No, sir. 230, sir.
230. It is not there in this. I mean, track. It is not there. We have paper ID from 729 to 743.
Okay,
Is there anyone from 734 paper ID? Semanti Roy Chaudhary? Okay. So it's not there. So, okay, thank you all for sharing your work. So it's a nice sessions and nice work all of you are doing. So thank you very much. Thank you.
Thank you, sir.
Yes.
Thank you, sir.
सर मेरे तो ज्वाइन हो गया ज्वाइन हो गया
हाँ ये ऑन हो गया ना इसको ये कर दो तो स्टॉप ये था ना
अच्छा कौन अच्छा स्टॉप नहीं हुआ
मोर में था क्या रिकॉर्ड एंड
स्टॉप रिकॉर्डिंग अच्छा स्टॉप इसको भेजना है